What if I told you that right now there are real images, crystal clear, ultra-detailed photographs taken from the surface of an alien world? Not CGI, not simulation. This is Mars in 4K. And what you're about to see will change forever the way you imagine the Red Planet. Because the Mars you know is nothing like the Mars you're about to discover. Every image in this video was captured by actual NASA rovers rolling across the Martian surface, alone, determined, unstoppable. Spirit, Opportunity, and Curiosity. 3 robotic pioneers that have gone farther than any machine before them. Their cameras, once cutting edge, now reveal something extraordinary. A Mars that looks real, textured, vast, barren, beautiful. For the first time, these images have been carefully restored and rendered in ultra-high definition 4K, letting us see the surface of Mars as if we were standing there ourselves. The place names you'll see, like Glen Torridon, Namib Dune, and Vera Rubin Ridge, aren't science fiction. They're real, informal designations given by NASA's mission teams to map out this alien terrain. This isn't just a video, it's a window, and it opens onto a world few have truly seen. Let's get one thing out of the way. The reason we don't have high-definition video from Mars isn't because NASA doesn't want to show us. It's because they can't, at least not yet. You see, while the cameras on Mars rovers like Spirit, Opportunity, and Curiosity are incredibly sophisticated, designed to survive harsh radiation, dust, and extreme cold, they're limited by one simple truth. Mars is far, really far. Depending on the orbit, the Red Planet is between 54 million and 400 million kilometers away from Earth. That's like trying to send a message across the solar system using a walkie-talkie in a thunderstorm. And it's not just about the signal getting there. It's about how fast it can get back. The Curiosity rover, for instance, transmits data back to Earth at just 32 kilobits per second when communicating directly. That's slower than the internet your parents used to complain about. Now, you might be thinking, why not just upgrade the Wi-Fi? Well, there is a workaround. Orbiters like the Mars Reconnaissance Orbiter act like a kind of space-based relay tower, catching the data from Curiosity and forwarding it to Earth at up to 2 megabits per second. Much faster, yes, but there's a problem. This connection is only available for around 8 minutes per Martian day, which is called a sol. Imagine trying to upload hours of HD video with only 8 minutes of Wi-Fi per day. Instead of video, NASA prioritizes images. Still, high-resolution photos, often dozens per hour. Because Mars doesn't move much. No flocks of birds, no wind-swept trees, no bustling cities. So why burn precious bandwidth sending 30 frames per second when one perfect image tells the story? Each image that comes back is a piece of the puzzle. An out-of-context, dusty snapshot of an alien landscape. But once they're all stitched together, that's when the magic begins. And what you're about to see was built from that magic. What you're watching isn't animation. It's not a simulation. It's real footage stitched together from thousands of individual photographs captured across 2 decades of Mars exploration. But how do you turn still images into a journey? It starts with mosaics. When a Mars rover captures its environment, it doesn't take a wide panoramic shot like a smartphone. Instead, it takes a series of overlapping, high-resolution images, tiles, one frame at a time, like a scanner sweeping back and forth across the surface. Each photo is carefully planned, each angle calibrated. It's not just point and shoot. It's engineering precision. But back on Earth, those raw frames arrive as scattered fragments. Some are overexposed, others shadowed. Some have missing pieces. Sometimes the lighting changed mid-session. Dust, blur, even lens reflections. To create a single usable scene, teams have to color correct, align, and stitch dozens, sometimes hundreds, of images into a single continuous panorama. That's why you may notice black gaps in some frames. Those are places where no image was captured, either due to limitations in the rover's position or to protect power. And once a full mosaic is created, the team adds motion. Not by animation, but by using slow, cinematic panning across the panorama at 60 frames per second, preserving the ultra-high definition detail. No zooming in, no digital stretching. What you're seeing is Mars, exactly as it was photographed. Only now, it moves. This technique gives us something we've never seen before, a first-person view of an alien world created without ever taking a single step. But some of these mosaics go even further, reaching pixel sizes so massive you can zoom in and still see perfect clarity. And one in particular stands above the rest. Of all the images ever taken on the surface of Mars, one stands out, not just for its size, but for what it tells us about the planet's ancient past. Captured between November 24th and December 1st of 2019, this is the largest mosaic ever assembled from the Martian surface. It consists of more than 1,000 individual images, carefully aligned and calibrated to create a seamless panorama. The final product? 1.8 billion pixels. Yes, billion with a B. To give you perspective, if you printed this image at full resolution, it would stretch more than a football field in width. Zoom in, and the details don't blur. Rocks, soil grains, wheel tracks, it's all there, unfiltered, untouched. But where exactly was this image taken? The location is a region known as Glen Torridon, nestled at the base of Mount Sharp, inside Gale Crater, where the Curiosity rover has been slowly climbing for years. Glen Torridon wasn't chosen at random. This area was theorized to contain clay-rich deposits, a geological signature that could only have formed in the presence of water. And on Mars, clay is gold, because clay means one thing: ancient water. Stable, persistent, not just a flood, but a potential habitat. Scientists believe that billions of years ago, this area may have been a lake bed, fed by flowing rivers, shielded from radiation, and possibly even habitable for microbial life. As the rover panned its cameras across Glen Torridon, it wasn't just capturing pretty scenery. It was documenting layer upon layer of Martian history. Sediments shaped by time, by erosion, by the quiet presence of water that vanished long ago. You can see the texture of the land, the tiny ridges where wind has swept through, the cracks in the clay that hint at drying and shrinking, the subtle shifts in tone that suggest the presence of different minerals. This isn't just a picture. It's a geological map, a time capsule, and a work of art all at once. And even though the image is silent, the story it tells is deafening. We are looking at proof, not theory, but evidence, that Mars once had water, possibly in lakes or shallow seas. It changes how we see this planet. It reframes the question from, was there ever water on Mars? To, what else was there, and could something have lived there? What's even more fascinating? This isn't the only surprise that these images reveal. Because the next chapter doesn't just change how we see the land, it changes the sky above it. You've seen the Martian surface. Now, look up. Sometimes the sky above Mars is a faint, dusty red, like a planet trapped in permanent sunset. Other times, it looks strangely familiar, a bright blue sky, almost Earth-like. So, what's real? Here's the truth. Both are, in a way. Mars has a thin atmosphere made up mostly of carbon dioxide and filled with ultrafine dust particles. These particles scatter sunlight in a different way than Earth's atmosphere does. On Earth, tiny